Exam walkthrough for you from oscillations. A mass is hung from a spring and set into vertical oscillations. The mass is then changed so that the frequency of oscillation doubles. The amplitude of the oscillation is unchanged. Which of the following quantities is also double? So we know that first it says maximum acceleration. So we know acceleration is equals to minus omega square x. Okay, and it says that the frequency is going to be doubling. So we know omega is 2 pi f. So A is equals to minus 2 pi f square x. So A is directly proportional to f square, which means that if the frequency doubles, right, if this frequency will double, the acceleration will increase by 4 times. So this is wrong because we want to see which doubles. For kinetic energy, we know half mv square, and we know v we can write as half m r omega square, right? And we can write this as half m 2 pi r f square. So ke is directly proportional to f square, which means this also is wrong because if frequency doubles, then the kinetic energy will increase by 4 times. Okay. What about the maximum velocity? We know x is equals to a cos omega t. We know x is equals to velocity is equals to a minus a omega sine omega t. So if the omega value I can write as v is equals to minus a 2 pi f sine omega t, then v is directly proportional to f. So this is fine. This one will work. But let's just see d as well. t is the time period. We know frequency is equals to 1 over t. If frequency will double, time period should decrease by 2. So it should decrease by a factor of 2. So this is going to be long. So it's going to be CS answer. Okay, a little tricky, but you should be able to just use all your formulas and your knowledge to be able to do this. Next. Okay, so I have the question. A mass oscillates with the simple harmonic motion, and you have the VT graph, and you have to change this to the displacement time graph from the given options. So the way you do this is, you know that the velocity time graph is the gradient of the displacement time graph. Okay, you're gonna do it that way. Okay, so our gradient is going to be 0, so we're going to start with 0, and then our gradient will go from 0 to here, right? This is going to be our gradient. So our gradient will be negative. Okay, so it will be something like this. So it will go from 0 to negative, okay, and then it will decrease to 0 again. So it will be a cos graph basically, right? So it will be a cos graph of 1.5 cycle. So this is 1 cycle plus a half cycle. So it's going to be something like this, right? So this is 1 cycle and this is the other half cycle. You can also think of it, yeah, this is the best way to think about it. It's the gradient. Now, the way I like to think about it is, if this is for math students. For normal students, you can do this. Math students, yeah, you should know that minus sine graph, if you integrate this, you're gonna get cos theta. So easy, right? So you can do that as well, and then you can just see this number of cycles that are there, and you can draw it out. So the answer is going to be A. Teacher is teaching her class about the phenomena of resonance. To do this, she uses a drinking glass to produce sound in 2 different ways. When the glass is gently struck, the glass emits sound for a short time. When a wet finger slid around the top of the glass, it produced a loud continuous sound. Explain these observations in terms of resonance. So first, when the person struck the glass, that set the glass into an oscillation. Okay, but in this oscillation, the driving frequency wasn't equal to the natural frequency. So the total energy decreased, And because of that, we know that total energy is directly proportional to the amplitude. The amplitude of the oscillation decreased and the oscillation eventually died out. But when the person, he slit the glass around the top, that's when the glass again started to oscillate. Okay. And when the glass started to oscillate again, this time the driving frequency was approximately equal to the natural frequency, and there was a maximum energy transfer. This is an exam point. Memorize it. There was a max energy transfer. Because of this max energy transfer, the total energy was greater, and the amplitude this time was greater, and it then produced a loud continuous sound. Okay. And the reason this amplitude is decreasing here actually would be because of damping, right? So because of that, it would be decreasing. Yeah, so that would be your answer here. So striking the glass sets it into an oscillation. The energy is transferred from glass and the amplitude decreases. The oscillation is damped, the amplitude decreases. That's totally fine as well. Then you slide, sliding a wet finger on the top of the glass drives or forces the system into oscillation again. Right, now the reason you have to understand this free oscillation, and they tell you about a driving oscillation here, is because on the top, if you remember, it's gently struck and then the glass emits for a short amount of time. So you're gonna strike the glass and it is going to move on its own without any external force on it for a short amount of time. So it's in free oscillation. But with the second one, you're sliding your hand around the glass. So you're providing a driving force in that case to keep the glass moving. Okay, so keep that in mind as well. Okay, so the sliding the finger on the top of the glass forces the glass into oscillation. Driving frequency is approximately equal to natural frequency of the glass. Resonance occurs, there is efficient maximum energy transfer of energy, and the amplitude increases. Okay, so these are your 6 marks. Usually mostly the same stuff. The man is about to dive into the sea from a high diving board. The board is horizontal. Before he walks to the end of the board, the man stands on the end of the board. It bends as shown. By pushing on the board, the man displaces the end of the board a small distance downwards. The man and the board then oscillate with approximate simple harmonic motion. State the conditions for simple harmonic motion. Again, pretty straightforward. I have actually said it a lot of times, so I'm now just pasting the mark scheme because you should be familiar with this. It's kind of just a regular thing that the resultant force is directly proportional to the displacement from the equilibrium position, and its resultant force of the acceleration is always acting towards the equilibrium position. So you should be memorizing these points and understanding them and then memorizing. It's just stated, so you just have to write it down. You don't have to explain it. Next is a man stands at the end of the board. The board is in equilibrium when the end of the board has displacement of 18 centimeter. The mass is 75 kg. The board obeys Hooke's law as a deform, so that the stiffness is as follows. So you can simply say F is equals to minus kx, and then the force is just equals to mg. So mg divided by x is equals to k. That's going to be 75 times 9.81 divided by 18 times 10 to the power of minus 2. That's going to give me 4088 Newton per meter. Okay, remember this is the restoring force, which is just equals to the force that's exerted, mg. Okay, next part. Calculate the frequency of oscillation of the man on the board. Okay, so we know the time period is equals to 2 pi square root m over k, and when the frequency is 1 over 2 pi square root k over m. That is 1 over 2 pi square root 48088 divided by 75. So that's going to give you 1.2 hertz. Okay. If the amplitude of oscillation is large enough, the man will lose contact with the board at the point above the equilibrium position. So this is the man standing on the board. And if the amplitude they're saying is large enough, then the man will lose contact with the board above the equilibrium position. So as the man is so MA is equals to the So we have two forces on the man, the reaction force and mg. Okay. Now, when the man loses his contact, remember this is reaction force is a contact force. So the man will be in air. And when the man is in air, the only force acting on is mg. So what R should be is R should change from its value to 0. Okay. So it's going to be mg minus R. So R will decrease. It needs to decrease as displacement increases. Okay. When R is equal to 0, MA is equal to MG, A is equal to 0, man loses contact, is in free fall. Okay. Now I want you to be precise with everything. Tell them that this R is normal contact with the board. Okay. You have to specify everything.